Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, we are going to talk about how you can analyze spatial data. So let's begin. After you've imported your data, it's time to get into spatial data analysis. And I've explained all about importing your data in my previous video, so you can watch that. And in this video, in the following sections, I'm going to explain to you various querying, buffering, overlay, and classification methods to extract valuable information from your spatial data set. So the first thing we are doing is, understanding how querying spatial data works. So how you can write your queries in order to get valuable information from your data set. In GIS, you can query spatial data in two ways. One is attribute querying and another one is spatial querying. Attribute querying is just what it sounds like. You use this querying method when you want to summarize, extract, manipulate, sort, or group database records according to relevant attribute values. Okay, so for example, you just want to find areas located in a particular region. So you're just sorting or grouping data based on their latitude and longitudes value available in the data set. If you want to make sense of your data by creating order from its attribute values, then you would use attribute querying. Spatial querying, on the other hand, is all about querying data records according to their physical location in space. Spatial querying is based solely on the location of the feature and has nothing to do with the feature's attribute values. So attribute values could be something like, how much snow is there, how much heat is there, but all that is just set aside, and you just want to find where the place is located. So if your goal is to make sense of your data based on its physical location, then you would be using spatial querying. Referring back to the snow example, now this is the example I gave in my first video on GIS. So you can just check that if you haven't watched it yet. So in that, there was an example about snow, how much it is snowing in each of the cities, and you wanted to plot that on the map and also show how much snow is there on the map. So if you want to generate a list of all cities where snow depth was greater than 100 millimeters, then you can simply use attribute querying to select all records that have a snow value that's greater than 100 millimeters. Okay. But if you decide that you want to generate a list of cities with more than 100 millimeters of snow that are located within 100 miles of Grand Fork, which is the name of a place, so then you'd use both attribute and spatial querying, because now it's not just about how much snow is there, it's also about in which area. You want areas only within 100 miles of Grand Forks. You don't want everything. So to find areas within 100 miles of Grand Forks, you'd have to do a spatial query. But then within those areas, to find areas which have more than 100 millimeters of snow, you would have to do an attribute query. Next, we are going to see buffering and proximity functions. Within a GIS project, you can select or extract spatial features based on their physical proximity or nearness to a point, line, or polygon by using buffering and proximity functions. Okay, so if you want to find out how close some area is to some other area, then you would be using buffering and proximity functions. Buffering and proximity functions are fundamental basic spatial querying methods. Proximity analysis is a spatial querying operation that you can use to select and extract features that are within a user-defined distance from your target. Okay, so almost like what we were trying to do, within 100 miles of this or 100 kilometers of this. Okay, and you can use proximity analysis to calculate distances between features or to calculate the shortest route in a network, right? So if you wanted to reach from one place to another, and you wanted to calculate the shortest way or path to reach there, then for that as well, you could use proximity functions, buffering functions. Buffering is a proximity operation that you can use to select and extract spatial features that are within a user-defined distance of your target feature. Okay. Buffering is a proximity option for doing just. And this figure here shows a schematic of a buffer zone Y. So this is, let me show you. This is the buffer zone Y, this line that you see, that encompasses all areas within distance D of a target polygon X. Okay, so this whole thing is a polygon X, and this is the buffer that we have created, buffer zone Y. What it shows is everything that falls within a distance D of this polygon X. So you can use buffer zone Y to isolate, extract, and analyze all spatial features within this distance D of the polygon X. So if I wanted to find out, let's say that polygon X is a complex, okay, building complex where people are living, and I want to find that within a distance D of this building complex, how many medical stores are available, then I would create this type of a buffer zone, and then within those buffer zones, whatever stores are there, I'll find those out and check if they are medical stores or not. So that's how buffering and proximity functions work. One of the most powerful features, now we are going to move on to using a layer overlay analysis, right? Because there are overlays when you're using a raster format. So how to use that to your advantage. One of the most powerful features of a GIS platform is its capability to overlay and derive meaning from multiple layers of data. And by using layer overlay analysis, you can apply multiple operations to multiple layers of data that overlap the same spatial area. So we saw in the previous video on, file formats, raster and vector, we saw that you can, when you're creating a raster format file, then you are essentially overlaying data. So in one layer, you're just, if you're creating a sort of a map, a raster format file for a street, a particular street, then in one layer, you'll just show the street. But then in the second layer, you'll add in buildings. Okay. So it's on the same street, you're just creating another layer of buildings. So when you have those kinds of layers, you can use layer overlay analysis to specifically analyze each layer. So union, intersection, non-intersection, and subtraction are a few fundamental overlay operations. Union operations, as the name suggests, they combine the total area of all features being overlain, whereas intersection would retain only the areas of overlap between the features being overlain. Non-intersection are the reverse of intersection. So they represent areas of non-overlap between the features being overlain. Okay, and lastly, subtraction is used to subtract an area from one feature based on the area of other features that overlay it. So this sounds rather obscure, but it's not so bad, and you'll come to know a bit about it from this diagram right here. So you can see how union is working. This is one layer, this is second layer, and if you wanted to analyze both together and you wanted features of both, then you would apply union so that both of them have their features used. And if you had intersection, okay, this is the original data. If you had intersection, then intersection would deal with only this much part, because that's the only part where these two layers are overlapping. So that would be intersection. Non-intersection would be everything other than this intersecting part. So it looks like this. Subtraction would be essentially subtracting one layer from another. So you're trying to subtract this big layer from this layer. So this part, which is common, is gone, and only this much part remains. So this is how overlay analysis is done. Overlay analysis is commonly used in suitability studies to determine which sites are best suited to support a particular function or type of business, right? So if you wanted to, start a particular business, make a construction in a particular area, and you wanted to see if that area was suited for your business operations, then you would do an overlay analysis. So essentially, if you have some data, plotted about, the heat in that area, the commercial aspects of the area, how many commercial businesses are running around that area, then you would do overlay analysis by analyzing each layer, right? So commercial areas would be one layer, then another layer might be representing how much heat is there in each area, how much water is available. So based on all that, you would decide whether or not to build your business, your construction in that area. For example, if you have to plan a settlement, a new town settlement, you can use GIS to overlay spatial data layers and analyze the land's proximity to potable water sources, right? Because you have to, that is essential to create a town settlement. Suitable terrain, you cannot just build a town settlement on a hill, right? Suitable soil type is required, bodies of water, and so on. And by overlaying all these layers, you can generate a map that shows which regions are more or less suitable to support this type of a planned settlement. In GIS, reclassification, which is the final thing we are going to study now in this video before we move on to an actual example in the next video. So in GIS, reclassification is the act of changing or reclassifying the values of cells in a raster file or the values of an attribute in a vector file. Now, although you can use layer analysis overlay operations to analyze more than one layer at a time, you have to perform reclassification on a layer by layer basis. You can use reclassification if you want to reassign a new set of values to existing cells or attribute values, depending on whether it's raster or vector. But you need the newly assigned values to be proportional to and consistent with the current values and groupings of those cells or attribute values, right? So you have a new set of values that you want to apply to your existing cells or attribute values, but you cannot just apply those directly. You have to make sure that they are proportional and consistent, with whatever the current values are there for those cells and attributes. Reclassification is applied to vector or raster data layers that generally represent attributes of the Earth's surface. In other words, elevation, temperature, land cover type, soil type, and so on. Okay. So usually when you have data layers that represent attributes of the Earth's surface, that is when reclassification will be applied. To fully grasp the concept of reclassifying data in a raster layer, imagine a raster surface where every cell is assigned a depth of snow. Okay. Every cell shows how much snow is there in the area. Simply by creating new groupings of depth ranges, you could easily reclassify this source data to uncover new snow depth patterns in the study area. To illustrate the concept of vector layer reclassification, consider that you have a vector polygon layer that depicts land cover across your study area. So we saw how raster layer reclassification works. Now we are seeing how you can do vector layer reclassification. So to do that, just for an example, consider that you have a vector polygon layer and it shows how much land areas are there in your study area. Okay, how much land is there? So you have polygons that represent lakes, rivers, agricultural land, forests, grasslands, and so on. Okay, so you have all these polygons representing all these forms of land. And imagine that you want to know where there's only water and vegetation. Okay, you just want to find out water and vegetation in this area, then how would you do that? So you can simply repackage your map by reclassifying all lake and river polygons as water and all agricultural, forest and grassland polygons as vegetation. Okay, so initially your map had, 5 classifications. It had lake, rivers, forest, grassland, and vegetation. But now you just want them to be classified as vegetation and water. So what you will do is you will just repackage your map, reclassify lake and river, all polygons which show lake and river as water, and all polygons that show agricultural, forest, and grassland as vegetation. So with this reclassification, you can identify water from vegetation areas without needing to give the map more than a sweeping glance, because now it shows only 2 things, so it's easier to make out what it is showing. In order to download the QGIS open source software that we talked about, you should go to this qgis.org site /for-users. This is the link right here. And then once you get there, you will see somewhere here it's written download QGIS for users. So you just have to click on get the installer. And there are many options available here. The one that I have selected is the long-term release, most stable version. And there are 2 versions here given for 64-bit and 32-bit. So depending on what your system is, you should select the version. So I have selected the first one, that is version 3.16 64-bit version. And you just have to click on it, and it's going to take a while to download. It's about 300 MB. Once it is downloaded, you just have to click locate the file which got stored in your download folder. Just locate that file and double click on it and run it, and it should take you about 10 minutes to finish the installation process. So it's very simple, very straightforward. You don't have to do much to install it. Once it's installed, you can go ahead and search for QGIS in your search bar right here and open it. So this is what QGIS will look like when it is open. Okay, on top in the title bar, it will be saying untitled project. So that means you've not saved this yet, but you can, of course, save it later on. And next, what I want you to do is on this, whatever project you're creating will be visible here. This browser panel right here can allow you to add to your projects if you have data sets or anything that you want to import. You could do that from here, and it provides options for Oracle DB2 everything. Layers can be added right here. Okay, so that means if you want to add layers depicting, showing polygons or something, then that can be added here. And here in the search box down right here, I want you to type world. So within this project here, you can see it's written coordinate, so just go there and replace whatever is there with world and press enter. And you will notice that you can see a sort of a map of the entire world right here. And on the left-hand side layers panel, you will see that world map is written here. If you want to zoom in or zoom out, you can just use the plus symbol right here. And you can zoom in into particular areas on the map. You can zoom out as well. Okay. So this is what it looks like. And now the thing with this is you could work with certain areas, you could create your own layers. I want you to go to your left-hand side browser panel and see over there where it's written XYZ tiles. If you just click on that small arrow, it will open it up and you can see something called OpenStreetMap. So right now this is just a world map. It just shows different countries and all that. But if you want to see the street view as well, then you just have to do this OpenStreetMap. You can drag and drop. So just click on it and drop it right here. And now what you see is one layer on top of the other. So the world map is actually a vector type format. We discussed two different types of formats for GIS. One is vector, another one is raster. So the world map is vector format and OpenStreetMap is the raster format. Okay. And if you just zoom in, you can see how detailed that is. Okay. For example, I could just zoom in on one of these sections. This is Argentina. And if I just zoom in, I can see the different things. Now, remember that for this to actually work, you have to be connected to the internet. So only then this OpenStreetMap is going to work. If you are not connected, you might just see the plain world map and no OpenStreetMap. Okay. And have to wait a bit for things to load. Okay, so once this is done, you can always turn on and off all the layers here. Okay, we've created two layers. One is the world map, another is the OpenStreetMap. So if you want, you can turn off one and turn it on by clicking this. Like if I remove the tick mark, then you can see there is no OpenStreetMap anymore. And if I do the tick mark, then it's still available. So this is how it works. Now you can create your own layers on top of this. So just, for example, if I want to create my own layer on top of this and, maybe create an island or something in this area, I could do that by just going here in this section. QGIS is actually something very vast and there are so many things here to play with. And you could always do all that by, reading the documentation, finding things out on your own. I'm just going to give you here the very basics of QGIS. Okay. Now, if you go here, you can see something called New Temporary Scratch Layer. This is the option. So just click on that and just give it some name. Give the new layer a name. I'm just going to call it band. Okay. And the rest of the things you don't need to fill out, but you should do the geometry type. So what kind of area do you want to mark? I think I'm going to go with the curve polygon. Once that is done, just click OK. And now you're ready to create your own polygons here. So what I want to do is I just want to create a polygon. In this area, I want to show some sort of an island or something. So the way I can do that is just go to this section on top and you can see here it's written, if you hover over it, it says I add polygon. So just click on that and now you're ready to draw your polygon and you can draw your polygon in any area you want by just holding your mouse button and then just stretching it and you can make your own polygon. So let's say this is a sort of an island, okay, that I want to create. Once you're done creating your polygon, just do the right click on your mouse and that means it's no longer drawing, but it has finished drawing. Now this polygon is, you can see it is yellow, but if you want, you can change the color of this polygon and make it whatever you like. You can style it. For styling purposes, you can go here, just click on this land layer, select that, and go to open this panel. So here you can see this panel is opened and you can select whatever type of style you want to give it. There are some predefined styles over here. Okay, pattern Zelda. And if you want to have your own color, you can have your own color as well. And you could create more polygons, whatever you like. You can add more layers to this on the map that's already available. So once you're done, you can also save your project. Just do Control S and save it. Give a file name over here. Just going to write my first QGIS project. So this is the file name. Save it. You can see now on the title bar, it shows me the name of this, my first QGIS project. And that's it. That's how you can create layers in QGIS, and you can also add your own data, and you can also try it out on your own by reading the documentation. So I hope you understood all this, and with this I'm going to end the videos on GIS, and I hope that I will see you in the next video, and thank you for watching this one.